Now, this is what we have to discuss for today. We are going to start with what we call Williamson synthesis. First of all, what do you mean by synthesis in organic chemistry, precisely speaking? Synthesis involve in the following. Number one, what are the reactants? You must know the reactants involved. It is very, very essential. That is number one point there. Then, number two, we have what we call conditions. What are the conditions required? That's another point there when it comes to sentences. Then, number three, named after who? Named after who? I don't know whether you have heard of this before, but in case if you have not heard of it, you need to know this now. Named after who? Okay, so if it is named after someone, there must be what we call reagents. The reagent is also named after that particular person. So if there must be what we call reagents, you must know what we call composition. Composition of that reagent. Take for example now, there is what we call Lucas reagent. Lucas reagent, what are the composition of the mixture? There is what we call zinc chloride and hydrochloric acid, freshly prepared one, at ratio of 1 to 1. That is the ratio. Then the last thing that you need there is what we call products. Products is very, very essential as well. Everything you are seeing here is talking about what we call synthesis. You want to produce something. Okay. So with respect to that, you must know what are the reactants, what are the two separate compounds that want to react together. Then there is something I should add to it again, although it is important. But most cases, students discard it because they find it difficult to understand. That is what we call mechanism. Every reaction that takes place, they have mechanism at which or in which they occur. Without the mechanism, then we cannot talk about much of this organic related compound. So all these things that are listed in this place, they are the one that we're talking about whenever you want to talk about what we call synthesis. So it may be Williamson synthesis, we have a Seychelles synthesis, we have a Randomundius synthesis, and so on. Now, but let me take it from this angle. When we're talking about reactants, two things, or three things, or four, they react together. Then, during the process of reacting, there must be a condition that must favor them. So, what are the conditions? Is it pressure? Is it temperature? You must look into this carefully. Or is catalyst that's involved. Okay. Now, the next thing is named after who? Named after someone. Who is that person? Is it Lucas? Is it Williamson? Is it Brett Test? And so on. Okay. If it is named after someone, then there is what we call composition of that stuff. Is the person, that person that discovered that thing, they named it after that person. We serve as what we call the what? The reagent. So that reagent has its own composition. For example, now look at what we call the Fehling's solution. There is Fehling's solution A and Fehling's solution B. What does this Fehling's solution A contain? It just contains what we call the CuSO4. Now, what does the Fehling's solution B contain? It contains what we call the sodium tartarate. Sodium potassium tartarate rather. That is what it contains. Now, that is that there. Then there is what we call products. What are the products that must be formed? What is the essential products? Different products might be formed from a particular reaction, but there is what we call essential product, the most important, the most wanted, the one that we wanted to produce. That is it. Then there is mechanism. Mechanism at which the reaction occurs is also important. Okay, this one exchange with this one. I'll be explaining the mechanism now with respect to what I have in this place. Now let us begin with what we have here. So we have what we call the Williamson synthesis. That is named after who? Williamson. Okay. The reaction involves nucleophilic substitution. There are some terms that we use here. You have to understand what they are all about. If you don't understand the term, then what is the SS? What is what we call nucleophilic? The word nucleophilic simply means lover of electrons. That is what it simply means there. Okay. They love it. They are the lover of that electrons, and in that place, they are usually negative. Take note of that. We have those that are negative among them. Okay, so those that are negative among them, it may be the one of a CH3 minus, it may be Cl minus, and so on. Okay, So in this place, they said nucleophilic substitution of alkoxide. Now, this alkoxide A, you have to know where it's coming from. Alkoxide ion from halide ion. Can you see? We have two ions in this place. So according to this synthesis, they said it involves heating, that is the condition, heating an alkyl halide. When we say alkyl halide, R represents alkyl. The halide there is the X there, halide. So halide, which is talking about the halogen, it can be chlorine, bromine, iodine, and in this place, with what we call sodium or potassium alkoxide. So that is exactly what we're talking about there. So the two things that are reacting together now is alkyl halide, or we have what we call sodium alkoxide or potassium alkoxide. Either of the two is reacting together. Now, when they react together, what is the product that will be formed? Okay, so let's look into this carefully. There is also what we call general method. Most of these syntheses, because they are very useful in organic chemistry, there's always what we call general method, that is general way of preparing them. So when we're talking about the general method, is the way of preparing a member of a particular homologous series. So once you produce one, it's the same method you continue to produce others. Okay, now for example, now the general method for producing this particular compound A, the compound you are seeing in this place is what we call the ether. Take note, that is the compound that we have here. Now if you want to prepare it, you react this one together, the one that you have in this place. Now when you react this one together with this, okay, it produces this one here, RO followed by R, then followed by NaX. That is it. Now, from this reaction that you have in this place now, let's find out. This is example here. This particular one, we call this one sodium ethoxide. As you can see, this is sodium ethoxide. Okay, so sodium ethoxide then react together with what we call ethyl chloride in this place. Now, heating is the condition needed there. Now, the product that will be formed here is what we call ethoxylethane. Look at it carefully, ethoxylethane. Then followed by what we call NaCl. So this is the typical example there. So when they ask you what is or describe Williamson synthesis, so this is what you are expected to give. If they ask for example,